Hello and welcome. In this tutorial we will explain how to make a connection between an Arduino Opta and a PC through TCP MODBUS connection through Ethernet. So we will be setting up the computer as the master and the Arduino Opta as the slave. The master will ask for orders, so it will say take this value and store it in this address of your memory, or tell me the value of an address that you have in your memory, and then the slave will comply or not. In order to show that this works, we will do this physical construction. So first of all, we will communicate the Opta and the computer through a switch with an Ethernet cable. And then we will perform a couple of reads and a couple of writes. So first of all, we will read the value of a button, which will be 0 or 1, and then we will transmit it to the computer through this connection. Then we will make an analog read of a potentiometer, so an analog value, which will be an unsigned integer, and we will also transmit it to the computer. Then we will actuate directly from the computer to an output. So we will turn on or off a light bulb. And finally, we will actuate a light bulb through indirectly by sending an analog value performing an operation, and according to depending of the value of the result of this operation with an analog value, we will either turn on or off this light bulb. As you saw on the diagram, we will need to connect the Arduino Opta and the computer to a switch. The switch is this one I got for 10 euros on Amazon, but you can do it by connecting your Opta either to the switch or to a router or however you want. So first of all, we are going to create a new project, which we will call project slave. And the first thing that we're going to do is to program the inputs that we mentioned before. So if we go back to the schematics, we said that we will be putting a button on input 5, it will be Boolean, and then on input 8 we want to do a digital, an analog reading. So we go to programmable inputs, and if you see here in the description, it says that it's already linked to a Modbus address, meaning that to use these inputs and transmit them, we don't need to do anything at all. We just assign the variables and they are ready to go. So for now, we set input 5 as a digital input. So we say input 5, and it's a digital, so it's Boolean OK. And then input 8, and we set it as an analog input and unsigned int. So this is ready to go. As we said earlier, we want the computer to be able to directly write on the output number 1. So to set that up, we are going to relay outputs. We see that it's already mapped, so we just need to choose a variable name, and that will work. So we will say output 1. And also we will be using another output variable, which is output 3. So we are going to set it up for later. And that's it. Now, to further demonstrate the capabilities of the software, we are going to take the value that we read, which we remember was an unsigned integer. We are going to divide it by 2, and we are going to transmit it to the computer. So to do that, we are going here to status variables, and we are going to create a new one, which will be called divided input, and it will be an unsigned integer uint. Okay, now we're going to compile. Okay, that took about 10 minutes. We needed to compile because if we don't compile, this variable will not appear when we're making the program. So now we are ready. We go to project. We're going to create a new program to make this division. So we're going to create a new program. It will be a functional block diagram. It will be called VD1. We're gonna put it in fast. And here in the different operators that we have, we go to arithmetic division. The result will be stored in divided input. Okay, so we're gonna flip it and we connect it here. We're going to divide by 2. So we're gonna take a constant, value 2, put it here. And finally, we're going to need the value that we're going to divide. So if we remember, we had it in programmable input, it was input 8, which was an unsigned integer. So we're gonna divide input 8 by 2. So we come here and we search for input 8. Okay, and it's here. So now we will have input 8 divided by 2 if we assigned to the variable divided input, and this divided input variable will be public and it will have this address. So now we are ready to send it. The last thing that we are going to do is prepare a variable that we will write from the computer, and if this variable is larger than 300, we are going to light the output at relay number 3. So to do that, we are going to parameters. We're going to add a new one, which we will be called written by PC, and it will be an unsigned integer. Okay, again we are gonna need to compile this, so we do, and now we are going to do this comparison. So again we return to our functional block diagram, we add a new line. So it will be a comparison, so we search for the operator, comparison greater, okay, so greater than, and now we want to compare something to the value 300, so we take the constant 300, and we are gonna wanna know whether the written by computer variable is larger or not. So we take the variable written by PC. Okay, so here. Now the result, we were gonna need to store it. So for that we are going to create a new variable. We go to global, we create a new variable, which is gonna be called comparison result. It's gonna be a boolean, okay? So we return now to the program, and here we are going to store the result. So we go to variables, comparison result, okay, here. We flip it, and now the final thing to do is to act on the coil that we mentioned, which is the coil 3, with this result. So for that we are going to create a new program. So we go to new object, new program. This will be a ladder diagram, which will be ladder 1. We are going to put it in fast as well. So here we are going to take the comparison result and we're going to write it in coil 3. Okay. Now we are ready to set up communications. That's what we're going to do. So we are going to go to our switch. We're going to plug the computer and we're going to plug the Opta. Since we have a connection only to the switch and not a router or the internet, we don't have an IP. Therefore, the network will be unidentified. And if we click there and we click again, we will fail to see an IPv4 address. So we don't know the IP, but we need an IP to configure this communication. So what we're going to do is write cmd, go to the command screen, and there we're going to write ipconfig. We write this command and we will read an IP address. And this is the address that we will use to set this communication. So in our case, it's 169.254.177.216. The only thing we need to do now is to create a new static IP for our slave, which will be the Arduino Opta. So it will have an address that we can decide, and it's gonna be 169.254.177. This must be the same, so these three parts you must respect, and then you can choose the last three numbers. So in our case, it's gonna be 070, and that's the IP address that we are gonna set up. Okay, so now we are going to configure the connection. First of all, we go to Ethernet, and here we don't have to do anything. Here it says that slave mode is always enabled, and the unit identifier is 255. So in this type of communication, we can have one master server, which in our case will be the computer, but then we can have many slaves. And this tells us that to identify this particular slave, it will be called 255. We will see later. Okay, so nothing to do here. And then we go to Sketch, and here we have to set up the IP address that we saw before. So we remove the comments, and I have already written the numbers, but here you write the IP as we saw before, and generally if you write these values here, it works. So you configure it kind of like that, taking into consideration again the numbers that you get from your network. Okay, so now we are going to check connectivity, and for this we're gonna have two ways of doing this. The first is through the use of CMD. So we're gonna come here and we're gonna type ARP/A, and here we can see on the devices that we detect, this one here, if you remember the address, is the exact address that we set up. So that means that we are detecting the device in the network. So this is good. This means that this will work. If not, if you don't want to do this, or even if it does not appear here, it's not that important when it is in the slave mode. It may not appear, and it's okay. So in any case, we're going to also use this tool, which is called QModMaster. This tool will create a virtual master for Modbus communication. So this will be the tool that we will use to give and receive orders. So we need to set up the connection. And here, what we have written is slave IP, which is the IP that we set up earlier at the slave. So this is the Arduino's IP, as we set it up. And then the slave address. You remember here that when we were in Ethernet, we had an identifier. Each device, each slave has an identifier. In this case, this device as a slave is identified as 255. So that's why here we have here 255. Now we're going to simply test the connection. So to do that, we can press connect, and here there's a green light, which is good. Then we can also see the exchange, if there are not, and we can see that we can send packets. So it is connected. In fact, we have now a master and the Arduino works as a slave. So the next thing to do will be to set up the physical structure of the, according to what we said earlier that we are going to construct, and then we will test it.